Hi there, geometry friends, and welcome to the Unit 10, Day 5 notes about quadrilaterals in the coordinate plane. So lots of graphs with x's and y's today. And we're going to be using our three most favorite formulas. First up, distance formula. There he is if you don't remember him. We're going to mainly be using the distance formula to decide if two sides of a quadrilateral are congruent to each other or if the diagonals are congruent to each other. And then we'll be using our BFF, the midpoint formula, to decide the coordinates of midpoints, and mainly to decide if diagonals are bisecting each other. So like if two diagonals have the exact same midpoint, that means they're cutting each other in half. And then finally we'll use our BFF, the slope formula, y1 minus y2 over x1 minus x2, aka rise over run, to decide if opposite sides are parallel, or like if two sides next to each other make a right angle, or if diagonals make a right angle. So like with our good friends the kite and the square, those diagonals cross at 90 degrees and are therefore perpendicular. Just a refresher that parallel lines are the ones that have the same slope, and if you have perpendicular lines where they're making a 90-degree angle like that, then we're looking for opposite reciprocal slopes. So please feel free to work at your own pace through these example questions. You'll probably be able to figure out what to do for most of them just by reading the directions. Or if you'd rather, you can just kind of follow along with me and use the video to check your work. So first off, we're here to prove that ABCD is a parallelogram by showing that the opposite sides are parallel. And this is an occasion where kind of doing a little sketch might help us out. So here's point A, point B is at 3, 5, that's right there. Point C is at 6, 1, right there, and then point D is at 4, 0. So if I need to decide if this shape is a parallelogram, one of the things I can do is just by checking to see if the sides across from each other are in fact having the same slope. So you can do this with the slope formula. So like if I wanted to check if AB and CD were parallel, then I could go and do some y minus y, or 5 minus 4 over x minus x. 3 minus 1. And that gives me 1/2 as my slope for AB. You could go down to CD, same exact thing. Y minus y, so 0 minus 1 over x minus x, so 4 minus 6. That's negative 1 over negative 2, and a negative divided by a negative is a positive. So you could use slope formula to check and see, oh cool, these two have the same slope, I've got parallel lines. Or something that you can also do that I kind of like better is just by counting the slope out on the graph, rise over run style. So to get from A to D, now that I'm checking my next pair of parallel lines, I have to go down 1, 2, 3, 4. So my rise is negative 4, and I have to go to the right 1, 2, 3 spaces. So my run is 3. And then I could just go check and make sure that BC has the exact same thing going on. So to get from point B to point C, I have to go down 1, 2, 3, 4, and I have to go over 1, 2, 3. So same slope, yay. Two pairs of parallel lines, so I do have a parallelogram. Very cool. Example 2, it says, given the points A, B, C, and D, or sorry, A, B, and C, plot point D to make a parallelogram. This one you really do want to do a graph, kind of get a visual of what's going on. So negative 2, 4, there's A. B is at negative 6, 2. C is at negative 7. Oh, it's going to go off the graph a little bit. Negative 1, so that's like right here. And then I need to draw point D to make a parallelogram. Alright, so this slope that I'm seeing right here, BA, that better be the exact same slope that I see from C to D. So I'm just going to count out that same slope again. To get from A to B, I had to go over 1, 2, 3, 4, and up 1, 2. So for point C to point D, I better do the same thing. Over 1, 2, 3, 4, up 1, 2. So that guy right there better be my point D. And I'll sketch in the rest of the parallelogram to make sure that it's all working out nicely. Lovely. Alright, cool. So last thing I got to do is just write down those coordinates, which were negative 3, 1. Sweet. And I'm off to my next question. So here I'm proving that something's a parallelogram, but instead of looking for parallel sides, I'm looking for sides that are congruent. So distance formula shenanigans. Ugh. This is where you're maybe going to want to team up with somebody at your desk, and maybe one of you could find AB, the other one could find CD, and you can kind of compare and see what's going on there. Just to get a good visual, I'll pop this graph up as well. So -3, -2, 2, -2, and 3, 1, and -2, 1. I'm glad I drew this out because I can tell from this graph that sides DC and AB are horizontal lines, so I don't even really need to do distance formula on those. I can just count. Let's see, from D to C is 1, 2, 3, 4, 5 spaces, so that's kind of nice. Don't have to do distance formula on those, but I probably will have to do distance formula to find AD and CB. So here's where you maybe want to team up with a partner. One of you could do BC and one of you could do AD, and just make sure that you get the same answer. I'll walk us through one of them. I'll walk us through BC. So my first set of parentheses are going to be x minus x, so 2 minus 3, and the next set will be y minus y. So that's going to be -2 minus 1. And what we need to be really super careful about here is when I do 2 minus 3 and get -1 and square it, and -3 and square it, I should only get positive answers underneath that square root, because negative times a negative is a positive, so that -1 squared is really just 1, that -3 squared is really 9, and then BC is square root of 10. Guaranteed you're going to get the exact same thing for AD, but I'll leave that part up to you. Cool. So example 4, I'm proving that something is a trapezoid by showing that one pair of sides are parallel. Alright, so A, B, C, and D again. This one's a little bit harder to graph. It's probably going to go off the graph a little bit. So I'm just going to use the fact that, let's see, A, B, and C, D, those are going to be one pair of kind of opposite sides. And then B, C, and AD, those are going to be another pair of opposite sides. So let's check out the slopes of these two first. So y minus y, 1 minus 1, and x minus x, 12 minus 2. Oh, I get 0 over something, which is just 0. I bet I'll get the same thing for CD. 4 minus 4 for my y's, and then 5 minus 9 for my x's. So once again, 0 over something, which is just 0. So those are both just horizontal lines. Those must be my two parallel sides. And to make sure it's not a parallelogram, I want to see different sides or different slopes for B, C, and AD. Basically, when you graph this thing out, it's going to look something like this. So BC would have a slope of 4 minus 1 over 9 minus 12, which is positive 3 over -3, or -1. And then AD, I see y minus y, so 4 minus 1, x minus x, 5 minus 2, that's 3 over 3, or positive 1. So this is a trapezoid because I have one pair of sides that are parallel or do have the same slope, and then another pair of sides that have different slopes. So very cool. This next part B, I'm not going to have us actually do. We'll just talk about how we would do it. It says, is ABCD an isosceles trapezoid? So that would mean that we would need those two sides that aren't parallel, BC and AD. I'd want them to be the same length, and I would use distance formula to figure it out. But again, enough of that for now. So moving on to our very last question in this kind of genre of question, And that's when we're trying to figure out like which kind of quadrilateral we're dealing with based on a very limited amount of information or just by looking at the angles. So if we saw both pairs of opposite angles congruent, that's going to mean we've got a parallelogram. But if only if two pairs of consecutive angles or next to each other angles are congruent, like maybe this one and this one were the same and these two at the bottom are the same, that's going to be our good friend the isosceles. Oh my gosh, spelling isosceles is so hard. Isosceles trapezoid. And then if you have one pair of opposite angles congruent, that's our friend the kite, where you've got two angles that are the same, but then the top and bottom ones aren't. So, kite. Very last, all angles 90 degrees. That's either going to be a rectangle or a square. So when I look down at this last example, example 5, it says, given the following angles, determine the best name for the quadrilateral. And I'm looking at this and I'm like, well, I don't know what to set equal to each other. Like A and C could be equal, and that might mean I have like a kite or a parallelogram or something. Or A and B could be equal, and that would mean I have like an isosceles trapezoid maybe. But here, it's not a matter of setting particular angles equal to each other. It's the fact that I know I've got a quadrilateral, and all four of those angles should add up to be my second most favorite number, 360 degrees. So I'm going to start by adding these four guys up and setting them equal to 360. And then when I'm done figuring out what x is, whoa, that was almost bad. When I'm done figuring out what x is, I can plug it back in and see how big each of those angles actually are. So first thing I'm going to do is just go through and combine some like terms. So I've got 3x's, 4x's, 2x's, and 3x's, 12x's. And then I've got 18, -4, 32, and 26. I think that's 72. Cool. And then I'll subtract the 72 from both sides and divide by 12 and figure out that x is 24. Yay, I'm done! No, I'm never done. I've got to take that 24 and I've got to plug it back into all these angles up top and see how big they actually are. So when I take 3 times 24 and add 18, I think that ends up being 90. Ooh, so I might have like a square or like a rectangle kind of action going on, but we won't be sure until we check the other ones too. So let's do angle B. 4 times 24 minus 4 is 92. Alright, so the square idea is totally out now. Alright, angle C. 2 times 24 is 48, plus 32 is 80. Okay, so like, it's looking like none of these angles are going to be the same. Angle D is 3 times 24, plus 26, 98. Alright, so none of the angles are the same. The opposites aren't the same. They're not all 90 degrees. So I think the best name I can come up for this thing is just a quadrilateral. Very exciting. Not. Alright, so now that we're kind of done with the stuff that's like distance formula-y, we're going to look at some problems that are a little bit more abstract. So we've got to give the coordinates of point D or point X without using any new variables. Basically what's going on is they're going to give me some letters that represent points in the coordinate plane, and I've got to use those same letters to determine like where any of these missing points are. So when I begin, I'm looking at an isosceles trapezoid, and I know that when I drop this altitude down here, it's going to cut that opposite side into two congruent pieces. So there's my origin, 0, 0. And to get out here to this point that I'm making now, I had to go to the left A spaces and then up 0. So to get to point D, that means I had to go to the right A spaces and then up 0. And we'll try another one. So parallelogram, we've got our origin point. To get out to this point, I had to go a distance of A to the right. So this guy right here, that I'm also making red, is a distance of A as well. And I'm starting from an x value of B, So then my first coordinate, I had to go B and then A, or A plus B. That length will be my x value. And I know that's kind of abstract and kind of weird, so just bear with me. Maybe if you have a question about it, write it right there next to it, and you can ask me next time. For the y coordinate, however high up in the air this dot is, that better be the same amount of how high up in the air this dot is. So the y value on that dot is c, y value on this dot better be c. That's a hard one. All right, two more. One is the rhombus, so I need to figure out what this point is. Keep in mind that rhombuses have diagonals that are bisecting each other. So like this y distance, 0 up to the point, was 2a. So that means here I had to go maybe down 2a to get to point D. And then I'm not moving left or right at all for that point, so it's just going to be 0 as my x value. And last one, it looks like this distance is S. Wait a second, just kidding, where's the origin on this? I guess this is the origin. This doesn't make sense. Because these are flip-flopped. Alright, so let's just omit this one. J.K. Lowell. And what I want you guys to do is I want you to try number 5 and some of the ones down at the bottom. This will be something that we work on together on Friday for sure. So maybe try these, do your best. And then there's a handout for you to work on that's a great review of everything. Remember that Friday is going to be our review day, and then next week we'll have our test. So anything that didn't really make 100% of sense today in class, make a note of it and be sure to ask me about it on Friday when we review. I'll see you then. Have a good day.